Hey, and welcome to Tweaking Tank AI. What we're going to do in this video is to simply prevent the tanks from firing, the AI tanks from firing until they're locked. And we're also going to prevent them from getting any closer than about 80 meters away so that they get to about 80 meters and then blow us out the water. Okay, see you soon. Okay, so let's get into improving a few things about this aiming. The first thing you'll notice is that these AI tanks, they fire off their weapons before they're actually locked. So let's start by sorting that out. So, oh, it's gone a bit funny, hasn't it? You know what I've done there, by the way? I've hit the the top left key on the keyboard above the tab under the escape, and that brings up the game console, which you may be familiar with from some Unreal games. Okay, so what we want to do then is in the Tank AI controller and the CPP, instead of just firing, what we want to do in pseudocode is say if, and then what is the state? The aiming component header file. Yeah, if aiming or locked only is what we want. So let's just pseudocode that in the tank. If aiming or locked, then fire is what we want to do. Okay, so how are we going to do that? Well, we need to be able to get the state from the aiming component. And at the moment, we don't have a way of doing that. Now, don't just make this firing state public. That's naughty because that would allow other classes to set the firing state. And as your project gets bigger, that means you're likely to end up doing that by mistake. What we want to do is make a nice safe void. Not void. Very easy to type void, isn't it? We want a method that returns the firing state. So the return type is firing state, and then it's get firing state, and then const because we don't want it changing any of the member variables. We're just getting the firing state. Let's go ahead and implement that. I'm going to use Visual Studio's create definition tool, but if you're in Xcode, then it's very easy to just go and write this over in the tank aiming component.cpp file. So I'm just going to make sure that it's done it right. It's kind of hasn't. It's saying return an firing state as a method. That's a bit weird, and it's not firing state, it's firing state. Remember, the member variable in question in the header file here is firing state. So the implementation, this is confusing for you Xcode guys, by the way. We're looking into the tank aiming component CPP here. We can just go to the tank aiming component. Here it is, there's a getter. In fact, I'm going to move that getter further up the class because I think it should be probably something like after, doesn't really matter, after tick, something like that. Okay, so it's a very simple const method that returns the firing state. Now that we've got that getter method, in the tank AI controller, we can ask this question, if aim or locked. We can actually ask it in code. If aiming component, because that's the thing that knows, get firing state equals firing state, colon, because it's a static. Well, in this case, it's an enum, but it's known at compile time. That's when you use your colons. If it's locked, that's the only time, actually, we want this AI tank to fire. And we'll worry about limiting the firing rate later. Does that make sense? Let's have a go. We're simply saying to the AI tanks, don't fire until you're locked, you crazy fools. Now, let's see if they actually get locked. This is going to depend somewhat on the acceptance radius that we have in the tank aiming component. Do you remember this thing here? This acceptance radius is very small. It may be that they never quite get locked, but let's see what happens. I'm going to go F11, go down the hill a little bit to where I can see them. Boom. Yeah, oh, they definitely got locked. Okay, no worries about them getting locked. But what they are doing is getting, I think, too close. They're kind of crazy, cheeky close right now. So are they aiming the right way? Let's just check that. They do appear to be. Is this guy going to shoot me? He's not locked. He doesn't want to think that he's locked either. You know why this probably is? It's probably because they're trying to aim at the bottom half of... Remember that the only thing they can aim at the moment is the tank root, i.e. its origin. And they probably couldn't quite get their barrels low enough. But the point is, they shouldn't be getting that close in the first place. So that's what we're going to tackle now in the second half of the video. So far, as a recap, what we have done is we have written a getter and then implemented it, which was super simple on the tank aiming component, and then just said to the AI controller, only fire when locked. Very, very simple. It reads almost like English. Now we're going to look at the acceptance radius. So not that, but in the, where is the acceptance radius? It'll be in the tank AI controller. We have an acceptance radius here. If you go to the header file of the tank AI controller, remember the acceptance radius is how close the tank AI can get. Well, what I want to do is I want to expose this to a blueprint, but we don't even have a blueprint for it at the moment. So you're going to do it. Here's your challenge. I want you to make a blueprint of the tank AI controller class. See if you can remember how to do that over in the editor. Then I want you to expose acceptance radius as edit anywhere. At least for now. You could make it edit default only, but let's go edit anywhere to start with. You'll see why. Code your default acceptance radius once you find it. So explore it in the editor. You may want to depossess the tank, play around with some acceptance radiuses, see how many meters. Remember that it's got 2 extra zeros on it, so 7,000 would mean 70 meters. And then put the default back into C++. Place your AI tanks in the world. And remember that if you do place your AI tanks or your player outside the nav mesh, then you may need to refresh your nav mesh. Currently, my nav mesh is only a subset of the whole terrain, so I'll probably expand that out as well. Because if you go off the nav mesh, things will stop moving. Okay, so pause the video and have a go at that challenge now. Okay, guys, let's get this done. This will be a bit of fun, sort of. Okay, so how do we do it? We go to the C++ folder, classes folder of our content browser. We go find ourselves the Tank AI controller, right-click it, and then say create blueprint class based on Tank AI controller. There it is. So I'm going to call it Tank AI controller underscore BP because that's how we like to name things, and create it. There it is. Now, just straight away, I'm going to put it in the blueprints folder just to keep the other one that's in their company and to be tidy. So here it is, doesn't do anything, doesn't need to do anything yet, but we are going to expose a property. So let's go ahead and do that. I'm going to move, of course, this acceptance radius into the protected section of the class. Why? Because the blueprint is a... Hold on, I can't talk and type at the same time. I can usually, but I can't right now. The blueprint is a child class of the C++ class. In fact, you can see that in the blueprint. It says parent class is the Tank AI controller. So that's exactly what protected means. It means that children can read it. So let's make this a uProperty. Edit anywhere for now. And I'm going to go category equals setup in strings. And I'm going to make a note straight away that consider defaults edit only, edit defaults only. If I actually put the word exactly like that, then I could always copy and paste it later. That's the handy thing about writing the actual code there. But you wouldn't normally write full coding comments. The whole point of comments is that you can use English. But in this case, if I'm saying I might change this code for this code, then it makes sense to put it so that I could copy and paste it later. Okay, so that's now exposed. Let's go have a little compile and watch the Tank AI controller blueprint as we do so. What I'm hoping will happen, I could collapse some of these categories down, is a setup category will magically appear in here. And we will be, there you go, able to set an acceptance radius. So let's try an acceptance radius of 150,000 meters. Compile, play. I love how fast you can compile blueprints, of course. And let's make ourselves larger and see how far away that is. Now they're not, are they moving? Yeah, they're coming towards us. Don't know, difficult to say. Difficult to say when they're shooting the hell out of us like this. So why don't we make it nearly impossible for them to shoot us just temporarily, or we could even take the tank aiming component off. The problem with that is it's a little bit tricky to do. So what's the easiest way of disabling this thing? Well, one thing would be to give them a pitiful launch speed of maybe 10, but remember what you had first. I think it was 20,000. So, okay, let's try again. The point here is that I want to be able to see how close they can get, and I can't do that all the time that they are shooting me. So what you can do with this edit, doesn't seem to be holding. They seem to be pretty close. So let's just depossess with F8. Click on this tank. Although remember, it's not the tank that's controlling this. It's its AI controller, which must be that one. That AI controller went from the left tank and that one for the right tank. The AI controller hasn't moved in the world. But if you look at the AI controller, then you can see the acceptance radius down there is 3,000 on that one. So what you're going to have to do is to tweak these things actually at runtime. So let's try 150,000. Then I can repossess my tank, get back into it, and then drive off and see at what point does that tank, whose AI controller I've just edited, start chasing us. Keep going. Doesn't seem to be chasing me at all. What's wrong with him? Oh, yes, he is. There he is. Okay, so the point is that's too far away. So I can go F8. I can click on this. I can pause the game even. Click on the controller in question, that one there. Try 80 meters, 80,000. And then I could resume the game and see what happens if 80 meters looks reasonable. Now remember, they won't necessarily stop exactly where you ask them to because they are going to overshoot, right? Especially if they're going that fast. So another way of seeing is I move away from him and see when he starts moving. Is this a reasonable place for the tank to get to? Yeah, that's probably about right for the enemy tank. We want it to stop around there and shoot at us. Cool. So we have our value. That's how we discovered our value. So it's not 150 meters, but it's 80 meters. So now we can make things simpler again. We can go back to the C++. We can code this in here, 80 meters. I will change it to edit defaults only and recompile. And then what you'll find will happen with edit defaults only is that the actual instance of the AI controller will no longer have that value on it. And the only place that you'll be able to change it is in the sensible place, which is the tank AI controller's acceptance radius over here. Okay, so let's have a look. In fact, we've still got that as 150, so that's going to override the blueprint, so I'm going to set it to 80 in here as well. The point of the C++ value is that if we make a new tank AI controller blueprint, then that's the value it's going to default to. So we want to put the value in here that we want, right? So C++ determines what the default in this box is, and then this box determines what actually happens in the gameplay, if that makes sense. So 80 meters is what we're going for. And we'll just save everything, play the game, make sure it's okay, and then hopefully we have made the improvements we want to, which is that they don't fire until they're locked, and that they stop about 80 meters away. Cool. I just need to re-enable the tank's firing. So instead of being able to launch at 4,000, let's put it back to 10 meters or centimeters per second. Let's put it back under the tank aiming component of the tank blueprint to 4,000, which is 40 meters a second, which is about 100 miles an hour. It's pretty slow, actually, for a projectile, of course, but that's fine for now while we're still using these beach balls. We'll upgrade our projectiles shortly. Let's just see how this is. Can I shoot them? Difficult, actually. Missed, of course, because the projectile's so slow, but they can certainly shoot me, and they don't crowd me. They don't get too close. So much happier with that, and I will see you in the next video. If you're still with me, then I just want to leave the code changes on the screen for you. That is the Tank AI controller C++. The aiming component is just a getter. And remember, you can always go to GitHub to get the code state. So I will see you soon.